Good morning, everybody. Just the camera. I'm logged in as Sydney King, but I am Russ Nicodem. I used his login, but welcome to everybody who is online. So today the format will be, I will go through some PowerPoints. We all hate long PowerPoints, so I will pound through some PowerPoints to give you the basics. And then I'm going to talk about two separate robotic safety kits. And we will talk about the differences between them and how we would choose each one to solve your applications. So with that, we'll jump into the PowerPoint. Could somebody confirm that you can see my screen and hear me properly?
Yes, we can hear you and see you.
All is good? Okay. I haven't heard anything, but so my name is Russ Nicodem, and I reside in Appleton, Wisconsin. I'm a safety application engineer for SICK Incorporated. And as Sydney said, we've been around since for about 40 years now. And we're one of the largest safety companies in the world. And we can cover your safety needs, everything from a risk assessment to turnkey solutions. But today we're going to be talking about robotic safety simplified. So here's our agenda. We're going to be talking about sensor solutions for robotics, talk about human robot interaction, the different types of interaction, coexistent, cooperative, and collaborative robots. Those are just different ways of interacting with your robot. We're going to talk about the safe robot packages and what components are used and why they may be handy for you. We'll be talking about the released packages. We're going to do live demos of the generic Sbot. And when we say Sbot, we mean Safe Robotic Area Protection. So just so we understand. And then when we say Sbot, Ethernet SIP safety, we're talking about safety over the network, and we'll talk about that more. We'll talk about the pros and cons and try and give you some valuable information. So first of all, our focus is, if you see on my screen, the top, Safe Robotics. The typical tools used in Safe Robotics are area scanners, safety controllers, light curtains, or door interlocks. Down in the bottom, this slide's a little bit confusing, but it's not overly. So you start on we have three different types of robot, three different ways of interfacing with a robot. So we have coexistent. That's this one on the far left. That means there's very little human robot interaction. It's kind of like me living with my daughter, and she's in the basement and I'm in her own room. And in order for me to see her, I got to knock on the door, and she says, "Stay out." That's coexistent, you know. And in the cases of a coexistent robot, it's usually behind a gate, and you'd have a door and you would have a request to enter. Like I say, just like living with my daughter. So you have very little interface with the robot, and that's your traditional industrial robot. But as we move forward, and you see this line here, increasing interaction, so then you jump to your cooperative robot. And now that's what we're going to be talking about today between cooperative and collaborative robot. So the cooperative robot is an industrial robot that is designed based on a risk assessment for a person to be able to go in, work with the robot, and come out in a safe manner. And we're experts in that. Then the third type of a robot is a collaborative robot. Now, a collaborative robot, people will use the terms like it's inherently safe and it has power and force limiting. Those are all good things, and they're great things. But some of the downsides of the collaborative robots, if you run them in collaborative mode, they're very slow. They have very low force. So sometimes, in most cases, you need to take them out of collaborative mode so that they can run faster and use more power and force. So that's what our systems do. So we're going to be focusing on cooperative and collaborative robots and safeguarding them properly. So we look on the left here, different workspaces versus shared workspaces tells you which operation you're using. At the end of the day, it doesn't really matter if it's cooperative or collaborative. The idea is that when somebody enters your robot area, you want your robot to react. You want it to slow down. You want it to stop. Do you want it to stay stopped and have to be reset, or do you want it to automatically reset? Those are the big questions that we're going to answer today. Making sense so far? So the first one we're going to jump through is the coexistent robot. Remember, that's the robot. Like I said, it's like living with my daughter. Everything's locked down and you only see her when you want it. And that's the same thing with this robot. And we would typically, we've got you covered on these coexistent robots. It'll be a robot that's behind a cage. You'd have light curtains for in-feed and out-feed, typically using muting. And then you would have doors, and your doors would be locked. So we have door interlocks. We have ones with, in the new ANSI standards require that you have a mechanism for somebody to not get locked into those cells. So we have ANSI compliant door locks and door interlocks, which meet the new standards, which were outlined last year in 2020. So in a nutshell, you would have light curtains and door interlocks, and the robot works on its own, and there's very little human machine interaction. We would work with that, and we would use the ISO, the safety standard 10218-2 would be the standard that applies to a coexistent robot. So the next type of robot is, and we're moving from left to right, from no interaction to some interaction. So this would be a industrial robot. It may not have power and force limiting. Doesn't matter, we can work with you. The operator and the robot complete their necessary stages of the process in the same workplace. That's the definition of cooperative. It's usually in loading and unloading operations, and the robot monitors the speed, the speed of the itself. It knows its own speed. It usually knows what zone it's in and things like that. What we do is we monitor the safe stop and the speed and separation, as they would call it in ISO 10218-2. So what we do is we say, hey, there's nobody in the area, robot, run full speed. When somebody enters the area, we can have multiple safety zones, and we can tell the robot, don't work to the left, don't work to the right, or come to a stop when somebody is too close to the robot. We'll be using kits, and we've created kits. So we're going beyond product now in this presentation. What we would call an Sbot Speed is a safe robotic speed kit. And when we say kit, we mean hardware, base hardware, laser scanner typically, a safety controller typically, and the safe logic that goes inside the safety controller. Now, the kit is freely expandable and it is changeable. So I call it a starter kit. So you get the starter kit, including the proper hardware, software, and the laser scanners or light curtains. What's nice about this is people will ask, hey, is this thing TUV certified? Or, hey, how do I write the program? We give you the base program, so then you can expand on that, change it, or leave it the way it is. And in our safety controller, it will meet your performance level required, because it's written by a TUV certified safety engineer. So what you're getting is peace of mind that the system is going to work. So this is an example of a coexistent, a cooperative industrial robot using a laser scanner and a FlexiSoft. And as the person walks into the cell, there's multiple safety zones, and we're telling the robot to react differently based on each of the zones that the person might be in. So what does SICK do and what don't we do? SICK is responsible for the monitoring of the safe stop. So we tell the robot to stop. Now it's the robot's responsibility to know that it is stopped. We do the speed and separation. So that means that we're detecting how far the person is from the robot and sending that signal to the robot. What we don't do is the power and force limiting. That's all within the collaborative robots. We're talking about collaborative robots now, and we don't do the hand guidance system. So we're doing the detection portion of the force, the 4 variables in a collaborative robot. We're doing 2 of the 4, and we'll be able to show that live. And again, the kits look something like this on the right, where you have scanners, controller, and then you've got also the software that goes along with it. So we do have a full range of systems, or kits as I call them, for robotics. On the left is the IO-based kit. So that's for your robots. It's we call it the generic. It works for pretty much every robot that we don't have a specific kit for. We call it generic because it gives you the very standard outputs that you would need on every robot: a slowdown mode, a pause or a stop mode, and a emergency stop mode. Those would be your 3 different modes. In your pause or controlled stop, that would be your automatic restart, where somebody walks in, the robot gets a signal to slow down, then they get closer and it stops. And then when they back out, it speeds back up. That's we have those signals in the generic, and it's just in inputs and outputs, very simple wiring, but it's based on IO, so you're a little bit limited on some of the complex things you can do with today's robots. We'll talk about that later. We do have robot-specific kits: Yaskawa, FANUC, KUKA, and a whole plethora of ones for UR robots as well. So what we are hooked up to here is an Omron robot, very nice Omron robot, and I ended up, we'll talk about that. I used a Ethernet SIP safety Safe Robotics system, and then I modified the outputs to give them dry contacts to do their slowdown and pause. So that's the beauty of these systems. You can take one and then they're freely modified. We don't lock down the software. So what is the working principle between these? There's 2 different types of Sbot, Safe Robotic Systems. One is a stop and one is a speed. So on the left here, you can barely see it, but there's a light curtain at the entrance of a robot. And then inside there's a secondary protective device, which would be a laser scanner. So what happens is a person steps into the light curtain. The light curtain tells the robot to stop. That's why it's called a stop. And then the laser scanner, as you see here, monitors inside the cell to make sure that it detects if the person is still in the cell. So you stop the robot and then you monitor that they're still in the robot. Notice this, that I can cover the complete area of the robot with one laser scanner. This is super important because we're the only people on the market with 275 degrees. So I can mount this scanner on this corner and I can catch both sides of the robot with one scanner, and that saves you a ton of money. But in this case, somebody breaks the light curtain, goes into the area. Now they're in the laser scanner area. They would call this restart inhibit. And then they have to exit the cell. And then you can either have it programmed for automatic restart or for that you have to press the reset button. Typically in these cases, you push the reset button to reset and restart in order to get your robot back up and running. And that's why it's called stop instead of speed. The one on the right is an Sbot speed. And of all the Sbot speeds, are designed for automatic restart, meaning that you're getting maximum production whether somebody's in the area or not. So somebody walks in up to the robot. In many cases, we have a warning zone. You'll notice this zone is yellow. This is an IO-based scanner. So it doesn't have multiple safety zones. So we use a warning zone, which is perfectly fine. We tell the robot to slow down, and then the person can work around in the yellow area using speed and separation monitoring as the safety function. And if they get within the red area, it means that the robot has to stop. That's their primary protective device. But you'll notice you've got a big area that the person can work around, and you don't have any gates or things like that. So these are freely accessible robots, and that's the way the market is going. So what's included in a kit if you use the stop kit, which is the kit that for robots that you just want to stop. You would get a light curtain mounting kit, your laser, a safety controller, the logic that goes along with it. You get some operating instructions, your E-plan, and your Systema file. So we give you everything that you need at least to get started with integrating safety into your robot cell. So that would be an Sbot stop. So I don't think I need to spend much time on the working principle, but it's one, the person walks into the area. Two, once they infringe the light curtain, it stops. Three, the person is standing inside the area. So that's restart, inhibit. And then when the person exits, you can use automatic restart because we've monitored inside the cell. We know nobody's there and they exited the light curtain. So what is that giving you? High productivity, reduced cost. You don't have to waste the extra 5 seconds it takes to restart the robot. So that's really what the benefit of these, besides the fact that they're easy to wire and you get the programs with them. You don't have to waste your own time, and then you don't have to question, hey, is my software correct? Is it TUV certified? Blah, blah, blah. We do that for you. At least the base program is done for you. When we start diving into the speed, Sbot, Safe Robotics Systems, typically includes a laser scanner and a safety controller. And this is hardware and software combined, two pieces of the puzzle. So we'll give you written instructions, which are really good. I've built probably 4 of these systems from the ground up, just following the instructions. Very well done. We give you the hardware, the TUV rated software. You do have to do a few things in the software, but we have instructions that tell you what to do. Connect, because it depends on which laser scanner you're using, which robot you're using. So you will have to connect some dots, but all the function blocks and all the logic is written for you. You just have to connect the dots within the program to meet your specific needs. So when I look at we started the Sbot systems quite a while ago. They have evolved quite a bit. So we're going to look at both systems of the Sbot. If I'm looking at an Sbot, Safe Robotic System that uses IO, remember that if you're using IO, you have limited numbers of wires, so you have limited numbers of fields that you can play with. So what we do in my first demo, which I'll show, is going to be exactly this. We have a warning field, which is yellow, a protective field, which is red. Somebody walks into my yellow zone, my first warning zone. Notice PF1 here is big. Once somebody walks into the yellow zone, we tell the robot, the warning field 1, to slow down. Then we have a timer in there and says, hey, it takes the robot 200 microseconds to slow down. Once the robot is slowed down, PF2, the protective field, gets smaller automatically. Why is that? Because you're already slowed down. So your stop time is reduced in half at least. So you don't need as big a protective field because the robot is already slowed down. So now you're giving your person more space to work and be more, your machine is working more efficiently. So now number 3, the person walks into the protective field, the robot comes to a stop. So one thing that people think, you know, hey, we don't care if this is an industrial robot or a collaborative robot. If the robot can possibly hit you in the head and in certain areas, which are no-go zones, the robotic standard says it has to stop. So that's why these systems can be used both industrial and for collaborative. Now, when somebody goes, number 4, if they were in protective field and they leave, the robot automatically starts to run in reduced speed. Then when they leave completely, it goes to full production. That's the beauty of these systems. So now, where is this all going? You know, life is changing so fast, and by the time I get one demo going, you know, there's a new one, and each one keeps getting better. There's 2 directions that I generally go. It's either the Core IO, which is what we just talked about, but more often now I'm jumping into the 21st century and using safe networks. And our safe network, we call it FE Pro. It's Ethernet IP SIP safety. So it's safety over the network, and the network is Ethernet IP, which most people know. So why is this important? First of all, there's no wiring. You power up the laser scanner and you use an Ethernet cable directly into a safe Ethernet module, and I get all of my protective fields. Nice thing is, notice all of these fields, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 protective fields because I'm over the network. What that means is I can really fine tune where my robot can and cannot be working based on where the person is working. So if a person comes into field 1, the robot can maybe slow down 25%. If they go into field 2, it slows down another 25%. So it's at 50% capacity. Now if the person goes into field number 3, the robot says, hey, I can only work on the right because the person's on the left. If the person goes over into 5 or 8, hey, it's going to be working on the left and not the right. So that's the beauty of going to the network scanners. If your robot has Ethernet SIP safety, which many of them do, it's a no-brainer at that point, because we bring in a laser scanner into our Ethernet port, bring Ethernet out the top, because there's 2 ports on our Ethernet card, and we send the signals over safe Ethernet to the robot. Now, in the case of what we're doing here, which we're going to show, I still like this system because if you don't have an Ethernet based robot, because I can do so much with the scanner. I can connect the scanner over Ethernet SIP safety, get my 8 multiple fields, and I would just add an extra module on here and drive dry contacts, which is what we're doing with this robot, to give your signals to your robot. So of all the kits, this is probably my preference because you have so many options when it comes to interfacing with your robot, and you have so many more safety fields. So instead of using a warning field, you're using all safety fields, and that's really nice. What's new in the Sbots? One thing that, here we're hooked up to an Omron PLC. We showed that we can connect to FANUC, Yaskawa. What we did, we partnered with UR. So many people think that a UR robot, because it's a collaborative, it doesn't need safety. Well, that's wrong. In most cases, you need safety if you want to run the robot in any type of higher speed application, if the robot could possibly hit somebody in the head, or if your end effector is got dangerous. So inherently safe means that it has the ability to go into a safe mode, monitor itself, and it has some safety capabilities built in. But we do have a system that does tie directly into UR, and it doesn't need any controllers or anything. It connects directly to the UR robot. So from that, we're going to go live. We'll start with my IO-based laser scanner, this one. Hopefully you'll be able to see it. Stop sharing my screen. Stop sharing my screen. Okay. Okay, look at Robert. Okay. So what we have going on here, can you see it big on your side?
Yep, we're good.
Okay.
Yep.
So this is a Safe Robotic Kit. Once again, it includes a laser scanner, a safety controller. This is my little robot. As you see here, you've got, I'm simulating a robot going in high speed. This is my little person that I created because it makes it easier to demonstrate. So I have a warning field 1. I have a protective field 1 and a protective field 2. You should be able to hear a little click maybe when I go into the area. So the idea is if a person comes into warning field 1, notice my robot slows down. That is going into reduced speed, power and force limiting, whatever you want to call it on your robot. So once the person is in here, this protective field shrunk to here. So now my person can work around the area without making the robot stop. But if they go in to the protective field, which would be common because in a collaborative or a cooperative robot, you're designed to work with the robot. You want it to stop. And we have built into the controller, the secret sauce is the sequence monitoring. The sequence monitoring says, hey, somebody came in, warning field 1, protective field 1, now they're in protective field 2. We know that's a normal operation. And then when they exit, the robot automatically goes into high speed. Once again, they come in, I slow down, I can work around the robot, I stop. And as they back out, say they don't back out all the way, my robot starts running again. That does 2 things for you. It increases your productivity because now at least I'm getting some productivity. And 2, it reduces wear on your robot because I'm going from stop to slow speed and then from slow speed to high speed. Instead of going digital from high speed to stop and stop to high speed, you're able, it's like driving your car and tapping the brakes ahead of time. You're already slowed down. And then gradually increasing your speed, you're going to increase the productivity and you're going to increase the longevity of your robot. So now the big question that people ask, and this is one of the things, if the person walks in to the robot and the robot stops, and then the person decides he's going to jump up on the robot because something got jammed or whatnot. And then he gets off the robot and he backs out. Well, what happens? The robot doesn't start. That's sequence monitoring. It says, hey, somebody broke the sequence. And if they break the sequence, you have to reset the robot. So I've got reset. And you would normally have a restart. Now my robot takes off again. That's really at the heart of the safe sequencing. And that safe sequencing will carry over to when we talk about the network scanners. Any questions on this?
So yeah, so basically you touched on the fields. So how many fields can you technically have for this particular, because what's nice about the scanner is also you can see on the front of it, it shows you the LED light when you're getting close, when it's red and when it's green and where you're at. So as far as fields, I know there's different kinds of applications out there and also using the e-stop. So you just demonstrated how if someone were to jump over and bypass, how it stops it. So any other way of doing that?
There isn't on when you use an IO scanner, in most cases, you only have one protective zone. So that the one downside, one thing you'd have to be careful of on if you're using this IO variant, and this is why we made improvements when you go to the network scanners, we're limited on our number of IO. So here we have warning, protective, and then if somebody were to, you would have to guard the robot on the sides or something to make sure that somebody couldn't get behind the robot in this case, because we wouldn't be able to detect that. So you'd have to take that into consideration with the risk assessment. But it's designed for a robot that is guarded on the sides, but you have a work area. And this would be the situation. Or if somebody did come in and then walked around and left the protective field without exiting the warning field, it would detect them there. So it's very good, but you're limited with warning and one protective field.
Okay, thanks.
So one thing that you'll notice here when you go IO is there is quite a bit of wiring, which is one of the things that gets diminished when you start to go with a network scanner. The wiring is not difficult, it's just that there's more wiring because your scanner sending signals to your controller sending signals back to the scanner, and it's sending signals to the robot. That all can be done over the network if you buy a network, a robot with Ethernet SIP safety, and then you cut it almost 100%. But if you just use the network-based scanner and network-based kit, and you can still go with IO inputs and outputs to your robot, that is still very, very common and probably the way I would recommend.
So which particular kit are you using right now for this application?
Well, this kit is called the generic IO. So with this kit, a couple nice things. One, it is all IO. So if you're not really comfortable with using Ethernet SIP safety, perfect kit for you. It does the functionality that you need. It's all built in. You get the software. It's a little bit heavier on the IO, just because you have inputs and outputs. But this would be, and you get the software free with this one, which is really nice. When you go to the higher end ones, there's a fee for the program. This one, if you ever want to just get started, this is a great place to start. If you're not comfortable with Ethernet SIP safety, not everybody is. So that's why I have two of them. I go with this one is very good. I go with that if you don't want Ethernet SIP safety, and if we want to go with a higher end, a more sophisticated solution, we'll show you next the Ethernet-based scanner.
Thanks, Ross. So we've been going for a while right now. Just take this moment to ask, does anybody have any questions or anything like that? If not, we can keep going. Just let us know. Give it a few.
Let's go to this one, and
Okay.
I'll show my screen once we explain it. Okay. Is it still big screen on your side?
Yeah, we're back live on
Okay.
our robot.
Okay, so what we have here is a my voice. So I'll just stop it here. This is our laser scanner. It's communicating over Ethernet SIP safety. So it's bringing in one line of Ethernet SIP safety in. So we're doing all of our protective fields over Ethernet SIP safety. I can add these IO modules. That's why I say it's a starter kit. I added this module, which is a relay kit. So if your robot requires safe relay contacts, I just slap on a relay kit and take an output, and I drive those dry contacts. This is your CPU, and this is the cloning module. One thing nice about these is they have the cloning modules built in. So you never have to reprogram after you've done your initial setup. So I dump the program that we already provide for you into the controller. I dump the program into the laser scanner. This is over Ethernet SIP safety. When I did this one, it automatically configured all of your Ethernet assemblies and everything for me. So it was very simple. So this is your Omron robot. And all we did was tie into the reduced speed, and we tied into the pause, the protective pause, but just call it pause. So when I step away from the robot, it should go full speed. I'll show you later why the reset button is on. I want not to have that, but okay. So when the robot's running full speed, when we start to enter the area, you'll notice the robot is going very slow. That's collaborative speed. Can't get much done in that speed, but at least it's getting something done, and I can work around the area. Then as soon as I go to work with the robot, take my work piece away. As long as I've continued the sequence, the robot will start working again. That's the basic concept of the Sbot speed. So now, one of the things that I want to show here, since we have multiple safety zones, so I'm going to pull up on my screen, and I'm going to have Sydney go behind the robot, and we didn't program this in, but I'm going to show you why you would want it, why it's important. So let me get my screen up here. Share my screen. Share screen. So what I have on my screen is the actual fields that are in the scanner, and these blue lines are us walking around the area. So what we have here is, move this so I can see what I'm doing. V-red, this is the reduced speed. The big field is my reduced speed. Sydney, walk on into the reduced speed a little bit just so we can show how it's working. And notice that it's red. All of the fields are protected. So Sydney's in the reduced speed, so now the robot's in reduced speed. So now Sydney, walk into the stop zone. Now he's in the stop zone. You should be able to see it on my screen. I can highlight that. So he's in the stop zone. Okay, so now Sydney back on out. The robot should, go into full mode, full speed. We're allowed to have this extra field. That's this field on the side here. It's called PF3, it's just what we called it, protective field 3. That would be your no-go zone. Hey, if somebody goes around there, the robot, and gets behind the robot, they could get hurt. We didn't program that in on purpose because Sydney is going to show us what can happen if you don't have this in. So robots are very well mannered maintenance guy, and he's got to work on the robot, and he's meaning well, but look at that. He's come back this way so I can see you. You're in the field. Come back this way, right? So before he would have gotten back there, see, we're in this red field, which we didn't program yet, or we didn't put in the program. That would be the field that would be the no-go zone. That would tell the robot to stop and to go into manual restart because somebody went behind the robot. So go on back there. So without that, you're kind of in trouble here because our maintenance guy could get hurt. So come on out.
So here's maintenance guy, robot right here, smashing the head.
Yep. You'll notice on my controller is the reset button will be lit up. So what that means, within my program, I have it set up in my program. I just didn't tie in the output. It would put the controller, would say robot stop, and you can't start until we reset again. So then you'd have to go into it, reset, restart, make sure that nobody's in the area, and you're good to go again. So that's the benefit. That's really the benefit of having the multiple safe zones. Notice there's no warning zones. All the fields are safety rated. So that's the one of the big draws to using the network scanners. It's that, and quite honestly, there's no wiring between the scanner and the controller. Now, the kit that we have here is designed specifically for FANUC, but as you can see, you just slap on a control relay and route the outputs to the control relay, and I can tie into any robot that I want. So another thing, we're running low on time here, but the other thing to remember is that SICK can also provide you with turnkey solutions. We can do the risk assessment. We can do the safety concept. We can do the installation, and we can do the validation. If you're not comfortable doing that, we do have a service organization, a very large service organization, where we can help you take your robots from A to Z.
So can you also touch on the software? I know we're using Safety Designer for this, and it's no cost to customers.
Well, yes. First of all, when you get your download, you'll get you download the software from the internet, and it isn't no cost. There is a fee for the Sbot software kit because it is created by a TUV engineer. The generic is, since it was our first one, does not have a fee, but the more advanced softwares do have a fee associated with them. I can show you why. So within your program, I just opened up an exact program for an Sbot FANUC. You have multiple tabs. It gives you data that says what each tab is doing. What are your inputs doing? Safe inputs from the scanner, discrete inputs from the XTIO, status signals. So there is a lot of work. You're getting quite a bit of value from this the software. So and you don't have to buy it if you don't want to, but if you want to know that all of your robots are going to act the same, and you want a program that's TUV certified, or written by a TUV certified engineer, it's kind of nice to buy the software. Now, you can modify this software, but it gives it, I call it a starter kit. It gives you the starter software, and then you modify it from there. But it's really nice to be able to see. It probably takes away maybe 10 hours of your engineering time. And the nice thing is, if you're going to deploy more than one robot, you can use the same starter kit software, and now all of your robots are going to act the same. There's nothing worse than one robot acting different than the other. And that's because two different engineers wrote the program. No, if you use this, keep using it, modify it however you need to, and you're going to be very happy because you're going to have consistency on the shop floor. Or if you're an OEM, you're going to have consistency on your product that you put out the door. You don't have to rewrite the program or redo it. You've got a baseline already done for you.
Yeah, that's why I wanted to kind of touch on that.
The other thing
Thanks.
that's nice about this Safety Designer, especially when we go in with the FE Pro or the Ethernet SIP safety, is I have one suite. You can see here my laser scanners programmed within the same software as my safety controller. So now the days of going back and forth, if I use a Rockwell PLC, I'm opening up Rockwell, or and then I got a program in there, and then I got to shift over and open up Safety Designer or FlexiSoft Designer. Now we've combined it into one software suite. So you have Safety Designer. I can go into my laser scanner. I can go into my FlexiSoft, all within one suite. You don't have multiple softwares that you have to learn, download, and all of that. So that's really nice as well. So are there any questions at this point? So with that, that was the part of our presentation. I just wanted to show you some of the other tools that we use. I'm not sharing my screen, right? So
Yeah, you're good. Did you want that over
I want to
there
show-
or did you want
I
here?
was just going to show you a couple of tools here. One of the tools, I'm not on the screen. One of the tools that I really highly recommend is this. This is called an alignment bar. It's got these little blue lights, and I've got a laser sitting right here. So you should be able to see. Let's see.
Yeah, we can see them right there.
Yeah, can you see that they light up? So this is what I call a laser finder. It's called an alignment bar. But what it's designed to do is to be able to tell you where your laser is. Our laser scanners can go out 90 or 9 meters. Well, at 9 meters, if your scanner is just sloped a little bit, you may not be able to find where your laser beam is. Remember, it's infrared. Oh, turn the camera towards me. So hopefully you can see that I'm able to pick up this laser with this device, and it turns red. It's a simple tool, but it'll save your butt when you're setting up your laser. I mean, if you're just sloped a little bit, oftentimes people will call me in and say, hey, my laser, I can't see it. And I take this out and I'll be like, oh, it's hitting the floor, and they won't know it. Or if you're getting a reflection of some sort that's just screwing you up, I can take this and come over here and say, where is my laser hitting on the wall? If there happens to be a reflector here or something, it would tell me where the laser is hitting. Some of the other things that we have, we talked about the stop kits. They use light curtains. Some of the nice things about our light curtains are different than other people's. It's got built-in LEDs, built-in muting, and things like that. So we have some really nice tools to be able to help you if you just want to go with components or you just want your robot to stop. Another thing is, and we'll be talking more in future webinars, this is the smallest laser scanner in the market. Highly recommend it. The things that make us different on both of these scanners is we use high definition distance measurement, which is a patented technology to make your scanner robust. Also, this is the smallest scanner in the world. We're the only people that can cover 275 degrees, which means I'm scanning all the way around the scanner. I can mount this on the corner of a machine like this, and I can scan all the way around 2 sides of a cell, and nobody else can do that. And the other thing is we have the longest range on the market, which is 9 meters. A lot of times you don't need it, but we do have it. And we have all of the network variants, EtherCAT, Ethernet safety, Profinet safety at work. So we do have you covered. And if you just want IO, we got you there too. So with that, this is the new robot from new arm-on robot. I don't know much about it, but
That's the RS4, I believe. R4.
so if you need a robot, or you need some robot integration, or you need some help picking out robot kits or hardware, give your All Control rep a call, and we'll be glad to work with you and make your robot safe. With that,
Yeah, we
thank
just
you.
want to say, if you don't have any more questions, just stay tuned. I know Russ went ahead and talked about the kits. So you have your light curtains with a built-in LED. These are something we're going to highlight down the line. This is a new product play that just came out not too long ago. The fact that it's only 80 millimeters in height with a scanning range of 275 degrees. Like I said, this is huge for the market. Instead of having, in a situation like this, having normally in old applications, you might potentially need maybe 4 scanners just to protect an area. In this case, all you need is 1 in the end, and you have your angles covered, and perhaps 1 in the back. And like you said, as far as sensing range, it's up to 3 meters. And as far as the microscan is concerned, I believe you have to 9 meters for protective fields. And so, yeah, so keep tuned. We have more products coming out. If you don't have any more questions, thank you so much for joining us in this episode today. And look forward to seeing you next time. looking at the chat.